Our goal is to be able to sketch them. Our means to the goal, 14 things we need to figure out. Is every graph going to have all 14? No. But we have to look for them. We start with our intercepts that we wrote about yesterday. We move to our discontinuities like vertical asymptotes and holes. We'll talk about other discontinuities like from square roots or logarithms or trig at the very end of the pre-calc. So we look for the denominator equal to 0. If there is a denominator, if there's not, then sweet, none. We think about end behavior, the limit to infinity. What does it equal? If it's a number, there will be a horizontal asymptote. The hint is if the degrees are tied or if the bottom wins. Oblique asymptote only happens if the top wins, but only wins by 1 degree. Then we have to do a little long division and figure out the line that is that slanty asymptote. Symmetry, we'll look at it, we won't stress too much. And then domain, we've already talked about those problems multiple times. A couple more seconds for those of you guys still writing. But for those of you that were here yesterday, was that enough? Are those all 14? No, that's only 8. Do you remember where the other 6 comes from? The quiz you did today, right? Critical numbers, increasing, decreasing. Critical numbers, increasing, decreasing, relative extrema. CalcAB, points and inflections. Are all 6? I think so. Can I go? Okay. But before we do the calculus, we better find the derivatives, right? Have we kind of learned our lesson with that? Trying to understand craziness when you're in the midst of a really hard derivative, that's not the right time. That's not the right time, which is why the ones today, A, because of time, and B, because of, I just wanted to see if you got the new ideas. I didn't give you crazy hard derivatives. Doesn't mean you still couldn't have made a mistake, but they weren't as crazy hard as others that you see. How do we find critical numbers? Come on, kiddos, you just did a quiz on critical numbers. What do we do? Set who equal to 0? The derivative. If he has the top, just the top, and if he has a bottom, the top and the bottom. True? Okay. Increasing, decreasing. Who do we do a sign chart for? Or of? For increasing, decreasing. Who's on top? We're checking F prime signs with F. What are we putting into the sign chart? Critical numbers and, don't forget them, discontinuities. Extrema. We're looking for changes in sign of F prime at existing points. What do I mean by that? I mean, there better not be a dotted line over the point where there's supposed to be a relative min or a relative max, because that wouldn't really exist, right? But there does need to be a change in sign. I'm not going to write them all because you guys should know them. If the first derivative changes from positive to negative, the function changes from increasing to decreasing, that's a relative max, and vice versa for a relative min. Pips. Who do we use? But we better write first. These are only possibilities, right? These are only possible inflection points. Second derivative, pitchfork. Got my double prime. If it has a top, equal to 0. If it has a bottom, equal that to 0 also. Concavity, we do a sign chart, right? But who's in the top of the sign chart this time? F double prime. What numbers am I marking intervals in the sign chart with? Possible, the pips, and who else? Don't forget, discontinuities. And then points of inflection occur when? There's a change in sign of F double prime. Make that clear. At existing point, because if it's continuity, remember it's illegal. So put them in the sign chart, but I can't say the pen function, not even a point. Hey, there's calc, right? Guess what? Notes-wise, this is section 3.5 done. Remember? I told you I was going to review. It was a summary. It's putting it all together. So at the very beginning, didn't I give you a function and I said, hey, we need to figure out his graph, right? And some of you started to freak out just a little bit. Be like, I just got my calculator. Well, we talked about all 14 of the identifiers, and step 15 is graph. So, why don't I have any of the 14 identifiers written? That's not the first thing you should do. In section 3.5 homework, that's not the first thing you should do. I don't think. I think the first thing you should do before anything else is find the, who you're going to need anyway? Derivatives. So find the y prime and find the y double prime. Okay, guys, how many derivatives have you watched me take over the past few weeks? Okay, so I already did them. I'm going to give you the answers. Why? You don't need me to teach you derivatives. You need to master derivatives. But that's you practicing and finding mistakes and fixing them and not making any more mistakes on quotient rule or chain rule or subtractions or additions or multiplications or anything else that you make mistakes on. Yeah. But that's you guys need to figure it out for yourselves. You just watch me all day long. It's not going to help at this point. Does that make sense? Okay, so let's write down y prime. Y prime. I got it to be -2. This is after some simplifying and fractions. -2 x squared plus 1 all over x squared minus 1 squared. Not only have we learned to simplify derivatives to make it match to a multiple choice answer, but also when we're thinking of critical numbers, oh my goodness, we have to simplify just to be able to find them with the picture. That's why I simplified the way I did. The second derivative ends up being 4x times x squared plus 3 all over x squared minus 1 cubed. It was a fourth power. One came out of both pieces on top and canceled. Oh, that's a strategy. Either way, do we have them to use them? So we're going to use them in a second. For all the calculus-ish stuff. So we have to do all the pre-calculus-ish stuff first. Ready? Okay. How do we find the x-intercept? Set the whole original function. Remember, no calculus, no calculus, no calculus. Whole original function equal to 0, right? So I set the whole calculus function equal to 0. I'm going to do it in black so I can't do it separate. Question, how do I solve? Multiply. Oof, he's gone. Oh, 2x equals 0? So what does x have to equal? Perfect. So the x-intercept is going to be x is 0 and y is 0. Okay, y-intercept, what do I do? Right? What happens? 0 over anybody besides 0 is? Oh, yeah, duh. If it hits the origin, isn't that the x and y-intercept? It hits both at once. Alright, whatever. I was lame. Vertical asymptotes. Someone pointed this out yesterday. I forget if it was period 1 or period 6. Who are my vertical asymptotes? So x squared minus 1, the denominator equals to 0. I can't factor because nobody up top matches that. Or his factor is x plus 1, x minus 1. So therefore we solve, we get. So we have DA's at holes. Is there anybody else in the denominator? Oh, so none. None. Okay. Horizontal asymptote. Ooh. The limit as x goes to infinity. Who wins as we look at them, guys? Degree test, remember? Who wins? Bottom. If the bottom wins, ooh, it's going to 0. Just pulling the top down, not letting him lie. I don't know, whatever. So therefore, where's my horizontal asymptote? At y equals 0. Oblique asymptote. Did the top win by 1? The bottom wins. Oh, none. If there's a horizontal, there will never be an oblique. Symmetry. Really? Huh? Let's see what happens when we plug in a negative x. That'll be 2 times negative x all over negative x squared minus 1. Isn't that negative 2x over x squared minus 1? Isn't that negative of just who we had to begin with? Oh, which symmetry flips the sign of everybody? Odd. He's odd, aka symmetric about the origin. Huh. Domain. Oh, we already know him, right? There's no other problems besides the denominator, and we already figured out that x can't equal plus or minus 1. Pre-cal. Woo! Done. At least as far as function analysis. Okay, so what time is it? Time for calculus. So I'm going to go ahead and go steal my little derivatives. I have them all ready to go. Hey, so something good in homework, even if you're like, I don't feel like tackling the whole thing, couldn't you tackle first and second derivatives of a lot of them? Mm-hmm. Make that little reference guide. I don't mind. Have it be something separate. All right, kiddos, critical numbers. What are we going to do? Good. Set the derivative equal to 0. So y prime, or negative 2 times x squared plus 1, all over x squared minus 1 squared. Top equal to 0. Bottom equal to 0. Guess what? The top can't be 0. It's going to be imaginary. Oh, so just the bottom equal to 0? Uh-huh. But guess what? Don't we already know those numbers? Aren't they vertical asymptotes? Alright, fine. So when we go to do our increasing decreasing chart, we're just going to put in our vertical asymptotes, negative 1 and positive 1. We're going to test into the derivative f prime, who's right here, or right here. If I plug in a negative 2, well, that squares to be a positive. Positive times a negative all over a positive, that's a negative. If I plug in 0, that's going to be a positive over a positive times a negative. If I plug in 2, positive times a negative over a positive. Well, that's kind of not very exciting. What's it doing? Strictly decreasing. Relative extrema. Do we have any? No. Fix. Alright. What do we plug in? Second derivative. Good. So 4x times x squared plus 3 all over x squared minus 1 cubed. Top equal to 0, bottom equal to 0. Bottom equals 0 at the vertical asymptotes we already know about, so forget that. Well, that doesn't help. And then top. He gets imaginary numbers only, but ooh, when does 4x equal 0? So we'll steal him along with the vertical asymptotes when we go to test our concavity. We'll use our 0 along with our negative 1 and our positive 1. Just a hint, there's going to be a point of inflection at x equals 0. Could we put all that together in a graph? I don't think so. But we're going to do more examples on Monday. If you look at the backboard, this homework is on Tuesday, but you just saw for anybody where it says, get a graph, sketch, analyze first. What do you have to find? First and second derivative. Maybe you want to just do a reference guide this weekend. That'd be a great idea. Kiddos, please. I've got points for meeting. Please use time well. Get some rest. Have a little bit of fun. So carve out calculus time. For your sake and for mine. Rest. Every single day for none.
It's frustrating.
Thank you. Oh. Mara, go in your walker.
Oh my God.
Oh, yeah, yeah.
So technically,